So before we move into circuits, I want to talk about a really cool phenomenon called electrical discharge. So electrical discharge is very related to static electricity, and also we get to talk about lightning. So let's talk about what electrical discharge is. It's a transfer of excess charge from two objects that have a charge imbalance. So two objects might rub together, and you might have one object be positive, one object be negative. This is called a charge imbalance. Charge imbalances are not stable, so oftentimes they will try to equal out that charge imbalance. So a really great example might be you have your wool socks on, you're walking across the carpet. By doing that, you're actually charging by friction. You're creating a charge imbalance. So if you touch a large neutral object like a doorknob, you are likely to have a wave of transfer of excess charge to you to even out that charge imbalance, aka a shock. So if you've ever felt a shock before, if you've shocked someone else before, it's because you had a buildup of charge imbalance. You've charged by friction somehow, by rubbing against another object, and now that charge imbalance, that shock, is trying to even itself out. Electrons always transfer from the more negative to the more positive object. That's again because only electrons can move. The greater the charge imbalance, the more noticeable the spark is going to be. So now we are going to take a look at a natural phenomenon like lightning that's actually going to help That's going to help us to demonstrate charge imbalance. So let's take a look at lightning and how lightning might actually work using the laws of friction. So the causes of lightning are not fully understood, but they can be simplified into dramatic electric discharge. So it's essentially like a giant shock coming from the sky. So let's start by talking about rain clouds. This is first how charge imbalance is going to happen. So we have water droplets within rain clouds are going to rub together. This is going to create a negative charge. So our water droplets rubbing together are going to create a negative charge. That negative charge is going to attract on the bottom of the clouds. So we have our negative charge that's been formed by our rain clouds and our water droplets rubbing together. Now we have this accumulation of negatives across the bottom of our clouds. Our ground at the very bottom is actually a very large neutral object. So you have our alternating positives and negatives. So you can see the ground overall is considered to be neutral. So our clouds have a charge imbalance. They want to get rid of this excess negatives. They are going to try to do so by dumping into the closest neutral object. That's going to be the ground. So what's going to happen is we're actually going to see what's called an induced charge separation. So those negatives from the clouds are actually going to influence the negatives in the ground. So if you can see the negatives in the ground moved away from the negatives in the clouds, that's because remember that like objects are going to repel. So the negatives that are in the ground are going to be repelled from the negatives that are in the clouds. They're going to want to move away from those negatives, and that's going to create an even greater attraction. Because if you can see, the negatives in the clouds are now more likely to be attracted to the ground because it's got a positive charge floating on top there. So the top of the ground now has a positive charge. It's going to attract those negatives that are in the cloud. What's going to result from that is going to be a large electric discharge from the clouds. That large electric discharge is going to be those negatives traveling from the clouds towards the ground, towards the positives. So the negatives in the cloud is going to be attracted to the positives in the ground. So this negative induces a charge on the earth. So let's look at that again. We have our negative. Is it going to induce our charge? And then that negative induces that charge. Therefore, those negatives are going to be attracted to those positives, and we are going to see a large electric discharge in terms of lightning. So again, we have our induced charge. We have our charge imbalance between the earth and the cloud. And what's going to happen? A large electric discharge in terms of lightning. So that's it. That's how our beautiful lightning works. If the discrepancy gets too big, an electrical discharge will occur in terms of lightning. And a little bit about lightning. This is just a summary here. So if you do want to copy this into your notes, these are the steps that actually cause lightning. Water droplets rub together. This induces a charge in the earth. It's going to create a charge imbalance between the earth and the cloud. And if the discrepancy is big enough, you're going to go ahead and you're going to see an electrical discharge occur. So that's how lightning works, all explained by physics. Pretty cool, right?